Now, in this question, we want to know how many oxygen atoms are in 150 grams of this chemical right here. And what we're going to do is we're going to take the number of grams of this chemical and we're going to go from grams to moles. And after we know the moles of this chemical here, we're going to go from moles to the number of molecules. And after we figure out the number of molecules that's within this chemical, we can then go from molecules of this chemical to the number of atoms of any one of these that we want. And we're going to pick the oxygen atom because we want to know how many oxygen atoms are in the number of molecules of this. And so what we're going to do is we're going to go from grams to moles using that a mole is equal to the amount in grams divided by the molar mass. And then a mole to molecules, what we're going to do is we're going to use Avogadro's number. And that says that every 1 mole is going to be equal to 6.022 times 10 to the 23rd power. And this will be molecules. So I'm going to write molecules here. And then we can go from molecules to atoms by using the chemical ratio. And so I'm just going to say the chemical ratio. And we get the chemical ratio from this chemical formula right in here. And so let's go ahead and get started with this problem. First, I'm going to take this 150 grams. So I'm going to do 150 here, and I'm going to divide that by 141. So I'm going to put 141 here, and that's going to be equal to 1.063, and that will be moles of Mg2SiO4 like this. And so I go from grams to moles using this right here. And now if I want to go from moles to molecules, I'm going to do this right here. And so let's go ahead and do that. And that says that we have 1.063, and that will be moles of Mg2SiO4 like this. I'm going to put this over 1 like that. And what I'm going to do now is I'm going to put moles on the bottom, and then I'm going to put molecules up top. And the reason why I'm putting moles on the bottom is so that moles here and moles here can cancel out, and then I'll be left with molecules up here. Now, Avogadro's number says for every 1 mole we have, we're going to get 6.022 times 10 to the 23rd power. And sometimes you might see atoms right here instead of molecules, but the reason why I picked molecules, not atoms right here, is because this right here is moles of this right here. And what this is right here is a molecule. This is not an atom. But if you ever see moles of just one single atom right here, then I put atoms right here. But because I have this as a compound, I have to put molecules there. And so when I do this number here times this number here and then divide by 1, I'm going to get 6.406 times 10 to the 23rd power, and that will be molecules of this Mg2SiO4 like that. And now to go from this molecules here, molecules there, to atoms there, I'm using the chemical ratio. And the chemical ratio is right in here. And so what I'll do is I'm going to take this 6.406 times 10 to the 23rd power, and that's going to be molecules. That's molecules of this Mg2SiO4 like this. And that's going to be over 1. And what I'm going to do is something similar to up here. I'm going to put the number of molecules of this Mg2SiO4 on the bottom, and then I'm going to put atoms of whichever one I want. And I want to get the oxygen, so the oxygen is right in here, and there is a 4 right here. So there's 4 oxygen atoms for every one of these molecules. So for every one of these molecules, there's going to be 4 oxygen atoms right here. And so now that I know that there's going to be 4 oxygen atoms for every one of these molecules, what I can do is take the molecules here and molecules here. Those can cancel out. I'll take this number here times this number here. And when I do that, I'm going to get that this is going to be equal to 2.56, and that's going to be times 10 to the 24th power, and that's going to be atoms of oxygen. And so this right here is going to be the answer.